This week, we're learning about sequences, and we're going to start by learning about two specific types. The first type is referred to as an explicit sequence. As the definition says, we can find any term in the sequence using a formula without knowing any other term. That's the key feature that sets an explicit sequence apart from a recursive sequence. Now, a recursive sequence, as the definition says, you can only find the next term if you know the previous term and if you understand the relationship between the previous term and the next term. Underneath each definition, I wrote an example of the sequence. So here's an example for explicit sequences, and here's an example for recursive sequences. Let's talk about some notation. This first part right here, A sub n, is going to stand for the value of the term, and then n is going to stand for the order at which the term appears in the sequence. So let's take this set of numbers for a minute. If I take a look at this, 0 appears first, 6 appears second, 12 appears third, and 18 appears fourth. So the numbers up top in red refer to the order in which each term appeared in the sequence, otherwise known as n. And the numbers in black refer to the value of that term, which is known as A sub n. So using this thought process, let's go ahead and try to see if we can find the fifth number in this sequence. So the way that I'm going to write this out is I'm going to say A sub 5, because we're looking for the value of the fifth term, is equal to 6, open parentheses, n, again, is the order at which that term appears in the sequence. So it's in the fifth place. So n is equal to 5 minus 1. So 5 minus 1, of course, is 4. And 6 times 4 is 24. So we're going to say A sub 5 is equal to 24. Now, if we look at the recursive sequence, it looks very much similar, but I must point out that inside the parentheses, it doesn't just say n minus 1, it says A sub n minus 1. So now we're going to try to find the fifth term except using this formula, and you're going to notice that our answer is actually different. So again, A sub 5 is equal to 6 times, now this is where things get a little bit tricky. So this is saying A sub 5, right, minus 1. So let's just go ahead and write that as is. So A sub 5 minus 1. So if I subtract 1 from 5, I get A sub 4. So A sub 4. So now the problem becomes 6 times the value of the fourth term. So if we refer back to our sequence up here, my fourth term was equal to 18. So this would become 6 times 18, which gives us 108. So my fifth term in my recursive sequence is 108 and not 24. So even though these two sequences look quite similar, what we have to realize is that in order to find my fifth term for the recursive sequence, I had to know what the fourth term equaled. But in order to find the fifth term in my explicit sequence, I actually didn't need to know any of the previous terms. So our IXL assignment today isn't focusing on writing formulas for explicit or recursive sequences. It's simply just trying to figure out what the missing term is in the sequence, which quite honestly is pretty easy. So basically what you always want to do is try to look for the relationship between each of the two numbers. So if I look at 34 and 26, I know I'm getting smaller. Same thing as I go from 26 to 18, I'm getting smaller. So here it seems like I'm subtracting numbers from each consecutive term. So if I look at 34 and 26, and if I subtract them from each other, I know that I'm decreasing by a value of 8. So now to make sure that this trend is holding true for the entire sequence, I'm going to test it a couple more times. If I look at 26 and 18, I also see that this is decreasing by a value of 8. Now let's try again. Between 18 and 10, I know I'm decreasing by a value of 8. So if I use this rule, I know that whatever the next term in my sequence is, it's got to be 8 less than negative 6. So negative 6 minus 8, which gives me negative 14. Let's try another problem that's missing 2 terms. So it's missing my first term and my fourth term. So the only way I can figure out what's going on in this sequence is looking at the relationship between these two numbers and between these two numbers. What I can say already is that this number is smaller than this number. So I know they're increasing in value. So I'm either adding something or maybe even multiplying by something. So what is the difference between 1.45 and 1.65? Well, it's 0.2. So now let's try to see if that's also happening up here. So if I take 2.25 and I subtract it, and I subtract 2.05, do I get the same number? Yes, I do. I get 0.2. So I know that I'm increasing each time by 0.2, which means this, my fourth missing term, is going to be 1.65 plus 0.2, which gives me 1.85. If I want to figure out what my first term is, I gotta find a number that when 0.2 is added to it, it gives me 1.45. So the first term has to be smaller than 1.45, and it has to be smaller by 0.2. So in this situation, to go backwards, I simply would just subtract. So I'm gonna show that up at the top. So 1.45 minus 0.2 gives me 1.25. Okay, so here I have another explicit sequence question, except it's with fractions. So I'm starting with 2/3, I go to 1/2, I go to 3/8, and I go to 9/32. So this type of question is going to require you to really understand what fractions we're dealing with and whether we're going in a positive or negative trend. So I went ahead and I converted the first 3 fractions into decimals just to help me out. And I'm noticing that I'm going from a larger number to a smaller number. So I'm definitely decreasing here. So maybe I should start by looking to see if there's the same difference between each one of these terms. So if I subtract the first 2 terms from each other, I know I'm decreasing by 0.16. And if I subtract the second 2 numbers from each other, I know I'm decreasing by 0.125. So clearly the relationship between these fractions is not determined by subtracting them from each other. So another option that I have is I could maybe try to divide the fractions by each other to see if that gives me the relationship. So this is going to require a little bit of math, and I can't use my decimal approximations because it's not going to give me the correct answer. So I'm just going to go ahead and use the actual fractions. So if I take 1/2 and 2/3 and I divide them by each other, so 1/2 divided by 2/3, this gives me a 4-story fraction. So I know I have to do keep, change, flip, which is going to give me 1/2 times 3/2, which is equal to 3/4. So what this is telling me is that each term is getting smaller and is only 3/4 the size of the previous number. So let's try this on another 2 pair of numbers in this sequence and see if this holds true. So I'll do 3/8 and 9/32. So 9/32 divided by 3/8. Again, this gives me a 4-story fraction, which we're going to do keep, change, flip. It gives me 9/32 times 8/3 is equal to, remember, always simplify before you multiply. So I know that the 9 and the 3 share a factor of 3 in common. So this becomes 3, this becomes 1. And I also know that 8 and 32 share a factor of 4 in common. So this becomes 1, this becomes 4. And clearly, we can see that our final answer comes out to 3 over 4, which is the exact same relationship that we saw between the first two numbers. So the way to get the fifth number in our sequence is simply multiply the fourth term by 3/4. So I'm going to do 9 over 32 times 3 over 4. And this gives me 27 over 64, 128, I believe. So this question is about a recursive sequence, and it wants us to find the sixth term in the sequence using the given relationship, and we also know what the first term in the sequence is. In order to find the sixth term, we actually have to find all the terms that lead up to the sixth term. So let's go ahead and start by finding the second term. So this is actually quite simple. So the second term, a sub 2, is going to be equal to 3 times a sub 2 minus 1. So a sub 2 minus 1 becomes 3 times a sub 1. And we know that the first term was equal to 0. So this becomes 3 raised to 0. And I know some of us are going to jump and be thinking that 3 raised to 0 is equal to 0, but actually any number raised to 0 is equal to 1. So a sub 2 is equal to 1. So now we know our second term, and we can move on to finding our third term. A sub 3 is going to equal to 3 times a sub 3 minus 1. So I know that 3a sub 3 minus 1 is simply just 3 raised to a sub 2, and a sub 2 is equal to 1. So 3 raised to 1 is simply 3. So a sub 3 is equal to 3. Now that you're getting an idea of what the math looks like, I'm going to go ahead and jump through the fourth and the fifth term so you can look over the math when I'm done. But you should definitely pause the video now and try the math on your own. As you can see, we have gotten to a very large number. So again, the a to the fourth term is equal to 27. And then when we get to a to the fifth, we have to raise 3 to 27, which gives us this massive number. So now we're going to carry out this process one more time to get us the sixth term. So I'm going to get a to the sixth is equal to 3 times a to the sixth minus 1, which is simply just saying a to the fifth. And we know the fifth term is equal to 7.6 times 10 to the 12th. And I mean, I don't know what this is off the top of my head. I'm definitely encouraging you to use a calculator. So it turns out that this number is so big that the calculator says it is undefined. LOL. So I'm pretty sure on IXL, it's not going to give you answers that are undefined. I pulled this question from our textbook. So don't worry. This is just an example. You're trying to learn the process. Now let's do one more problem on recursive sequences. Here it's asking me to find the fourth term. They gave me my relationship, which is a to the n minus 1 squared plus 2 times a to the n minus 2. And we have our first term in the sequence, and we also have our second term in the sequence. My apologies. So let's go ahead and carry out the math for this problem. So again, if I'm looking for the fourth term, I have to find the third term first. So a to the third is equal to a to the third minus 1 squared plus 2 times a to the third minus 2. So this becomes a to the second squared plus 2 times a to the first. So we know the value of a a2, and we know the value of a1. So a2 is equal to 4. So 4 squared plus 2 times a to the 1 is just 1. So this becomes 16 plus 2, which is equal to 18. So we know that a to the third is equal to 18. So now let's do the work for a to the fourth. A to the fourth is equal to a to the fourth minus 1 squared plus 2 times a to the fourth minus 2. So now this becomes a to the third squared plus 2 times a to the second. And again, we know the value of the third term, we know the value of the second term. So the third term was 18, so 18 squared plus 2 times the second term, which was 4. So here I have 324 plus 8, which gives me 332. So we know that a to the fourth, or the fourth term in this sequence, is equal to 332. So you have 2 IXL assignments over this. Remember to use your new account information that was just emailed to you. Do not do this on your old account.